Adjoint of the matrix is obtained by interchanging the diagonal elements. 2 and 2 will remain the same. It won't changes. We have to formulate this equation, and this equation can be solved using matrix method. First check whether it is in order or not. If it is in order, put it in the form of an order x, y, z and a constant. Usually you will get a straight question of solve a system of linear equation using matrix method. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss very important problems for 5 marks, that is solving a system of linear equations using matrix method. Now let us discuss. This is one of the application of matrices and determinants. So applications of determinants and matrices. We are going to solve the linear equations using matrix method. There are two methods. One is determinant method, another one is a matrix method. Determinant method you don't have in your syllabus. Matrix method we are going to use. Now let me discuss how we are going to solve. The solution of a system of linear equation using matrix method. To solve the system of linear equation using inverse by matrix method, just we are going to find the inverse for a particular matrix, then we are going to solve. Now let us consider the system of linear equation. Let us consider the equations a1x plus b1y plus c1z is equal to d1 and a2x plus b2y plus c2z is equal to d2, and third equation a3x plus b3y plus c3z is equal to d3. These are the three equations given. Then to solve these three equations using matrix method. Now let us check whether it is in order or not. X, y, z constant, x, y, z constant, x, y, z constant. First check whether it is in order or not. If it is in order, put it in the form of an order x, y, z and a constant. So x, y and z constant. Now just take the coefficients of x, y and z. The coefficient of x is a1, a2, a3. Coefficient of y is b1, b2 and b3. Coefficient of z is c1, c2, c3. So a1, a2, a3, b1, b2, b3, c1, c2, c3 are the coefficients of x, y, z. Now take this constant matrix d1, d2, d3. So b is equal to d1, d2 and d3. X is equal to, which is to be determined, is x, y and z. The value of x, capital X, is equal to x, y and z. The solution of the matrix is given by x is equal to A inverse B. Find out the inverse for that matrix and multiply with the constant, you will get the solution. So x is equal to A inverse B is the solution. The solution is given by x is equal to A inverse into B. What is x? X is nothing but x, y, z is equal to, what is A inverse? 1 over determinant of adjoint of A into the matrix B. A inverse is equal to 1 over determinant of A into adjoint of A. Just find out the inverse. For the inverse, just multiply with constant matrix d1, d2 and d3. You will get the solution for the system of linear equation in terms of x, y and z. Okay. Now let us take a simple problem. Let me solve with the 2 rows 2 column and 3 rows 3 column problem. So let us consider a simultaneous equation of 2 variables x, y and 3 variables x, y and z. Now solve the system of equation 2x plus 5y is equal to 1 and 3x plus 2y is equal to 7 using matrix method. So to solve this system of equation, let us put the equation. What is the given equation? 2x plus 5y is equal to 1 and 3x plus 2y is equal to 7. Check they are in order. Now take the coefficient. Matrix A is equal to coefficient of x is 2, y is 5, x is 3 and y is 2. Now x, this is contained x comma y, x is equal to xy, and matrix B is equal to, let me call it as B. B is equal to 1 and 7. Okay. Now the solution is given by, the solution is x is equal to A inverse into B. Now first find out A inverse. Now find out the determinant of A. Determinant of the given matrix 2, 5, 3, 2 is equal to 2 2s are 4 minus 5 3s are 15. This is equal to minus 11 not equal to 0. The inverse exists. Now, just find out the inverse. So, for that find out the adjoint. Straight away I will write the adjoint of this matrix. Adjoint of the matrix is obtained by interchanging the diagonal elements. 2 and 2 will remain the same. It won't changes. And changing the signs for the secondary diagonal minus 5 and minus 3. So, 2 minus 5 minus 3 is the adjoint. Now, therefore, A inverse is equal to 1 over determinant of A into adjoint of A. 1 over determinant of A is 11 minus 11 into 2 minus 5 minus 3 and 2. Now, the solution is given by x is equal to A inverse of B. That is equal to A inverse minus 1 over 11 into 2 minus 5 minus 3 into 2 into B. What is matrix B? B 1 comma 1 and 7. Simplify this. 1 over 11 into, along with negative sign, multiply, matrix multiplication. First row, first column, 1 2s are 2 minus 7 5s are 35. Again, second row, minus 3 1s are 3. Again, plus 2 7s are 14. So, this is equal to, this can be written as minus 1 over 11 into 35 minus 2. 35 minus 2 is minus 33 and 14 minus 3. 14 minus 3 is equal to 11. So, if you divide by 11, minus and minus gets cancelled. 33 by 11 is 3 and 11 by 11 is 1, that is minus 1. So, therefore, x comma y, the matrix x comma y is equal to 3 comma minus 1. That means x is equal to 3 and y is equal to minus 1. So, these are the values of x and y. This is how we are going to solve a problem connecting two variables x and y. Okay. So, just find out the inverse and substitute in the formula x is equal to A inverse B, you will get the solution. Now, let us come to the next problem. These type of problems are very, very important. So, you may expect this type of question for your 2022 examination, final examination. Usually, you will expect this question itself for 5 marks. Definite question. This is a definite question, right? Solve 3x minus 2y plus 3z is equal to 8. 2x plus y minus z is equal to 1 and 4x minus 3y plus 2z is equal to 4 using matrix method. Now, let us verify whether the given equation is in order or not. So, that is 3x minus 2y plus 3z is equal to 8. Second equation 2x plus y minus z is equal to 1 and the third equation 4x minus 3y plus 2z is equal to 4. So, x, y, z constant, x, y, z constant, x, y, z constant. So, the given equation is in order. Now, find out the coefficients of x, y, z. Let us consider A. A is equal to coefficient of x is 3, 2 and 4. Coefficient of y is minus 2, plus 1 and minus 3. Coefficient of z is 3, minus 1 and 2. Then, the matrix B is equal to, what is B? The constant matrix 8, 1 and 4. Then capital X is equal to X, Y and Z. What is the solution? The solution is X is equal to A inverse into B. Now, let us find out the inverse first. Now, I will go to the next page. Okay. The inverse is given by, for this matrix, find out the determinant first. Determinant of A. So, 3, 2, 4, then minus 2, 1, minus 3, minus 2, 1, minus 3, then 3, minus 1, 2. Now, let us find out the determinant of this. So, this is plus, minus and plus. This is equal to 3 into 1 2s are 2, minus into minus plus, plus into minus minus, 3 1s are 3. Minus into minus plus 2 into, this row and column is gone, 2 2s are 4, minus into minus plus 4, plus 3 into, this row and column is deleted, 2 3s are 6, minus 4. So, this is equal to 2 minus 3 is minus 1, 4 plus 4 is 8, plus 3 into minus 6 minus 4 is minus 10, minus 3, plus 8 2s are 16, minus 30. So, 16 minus 33. So, 16 minus 33 is equal to minus 17. So, therefore, determinant of A is equal to minus 17, not equal to 0, the inverse exists. Okay. Like this, find out the value of determinant of A. Okay. So to find the adjoint, find out the coefficient. So you know, for 3 rows 3 columns, the signs are plus, minus, plus, plus, minus, plus, minus, plus, minus, plus, minus, and plus. The diagonals are positive. Now just go on finding the cofactors. Cofactor of the first element 3. Cofactor of 3, A11. So this row and column is deleted. 1 2s are 2. That is 2 minus into minus, plus into minus, minus 2 minus 3. This is equal to minus 1. Similarly, cofactor of the second element minus 2 is the sign is negative. Just this row and column is deleted. 2 2s are 4 plus 4. 4 plus 4. This is equal to minus 8. Similarly, cofactor for the next element 3. The sign is positive. Plus minus plus. This is gone. Again simplify. 2 3s are 6. Minus 6 minus 4. This is equal to minus 10. For the first row, the cofactors are minus 1, minus 8 and minus 10. Let us take the cofactor. Cofactor of 2. This is negative sign. This row is, this row and column is deleted. What is left? Minus 2, 3, minus 3, 2. Minus into minus 2 2s are 4. Minus 4 minus, minus into minus plus 3 3s are 9. So this is equal to minus of 9 minus 4 is 5. The negative sign outside remains the same, minus 5. Again, cofactor of next element plus 1. Cofactor of 1 is equal to the sign is positive. This row and column is deleted. 3 2s are 6 minus 6 minus 4 3s are 12. This is equal to minus 6. Similarly, cofactor of next element is minus 1. The sign is minus, negative. This row and column is deleted. 3 3s are 9 minus 9 minus 3 3s, yes, 3 3s are 9 minus into minus plus 4 2s are 8. So this is minus of minus 9 plus 8 is minus 1. Minus into minus plus 1 it is. Now let us come to this last row. Cofactor of 4. Cofactor of 4. This row and column is deleted. Minus 2 1s are 2. Minus into minus plus 2 1s are 2. Minus 1 3s are 3. So this is equal to minus 1. Similarly, cofactor for the element minus 3. The sign is negative. Minus. This row and column is gone. 1 3s are 3. This is minus 3 minus minus. See, this row and column is deleted. 1 3s are 3. 2 3s are 6. Minus 6. So minus of minus 9. This is equal to plus 9. And last, the cofactor for the last element plus 2. Cofactor of 2 is equal to this row and column is deleted. 3 1s are 3 minus into minus plus 2 2s are 4. This is equal to 7. So minus 1, 9 and 7. So these are the cofactors. Now write down the cofactor matrix. Therefore, cofactor matrix C is equal to, simplify, write down the elements minus 1, minus 8, minus 10 for the first row. For the second row, minus 5, minus 6 and 1. For the third row, minus 1, 9 and 7. This is the cofactor matrix. Now if you transpose this, you will get the adjoint. Therefore, the adjoint of A is equal to C dash, the transpose of this matrix, that is minus 1, minus 8, minus 10 and again minus 5, minus 6 and plus 1 and minus 1, 9 and 7. This is the adjoint. Now find out the inverse. So A inverse is equal to, I'll come to the previous page. Now A inverse is equal to 1 over determinant of A into adjoint of A. This is minus 1 over 17 into minus, what is A determinant of A? Determinant of A, we got it as minus 17. 1 over minus 17 into adjoint minus 1, minus 8, minus 10. Minus 1, minus 8, minus 10. Second column minus 5, minus 6, 1. Minus 5, minus 6, 1. And last row minus 1, 9, 7. Minus 1, 9 and 7. This is the inverse. So this is how we are going to find the inverse. To find the inverse, this is the method. Now the solution is given by x. What is x? X is equal to A inverse of B. X, Y, Z is equal to A inverse. minus 1 over 17 into minus 1, minus 8, minus 10, minus 5, minus 6, plus 1, minus 1, 9, 7 into B. What is B? B is nothing but 814. 814. Now multiply this. Matrix multiply. First row, first column. That's it. So minus 1 over 17 into 8 ones are 8, minus 8, minus 5 ones are 5, minus 4 ones are 4. Second row, first column. 8 eights are 64, minus 64, minus 6 ones are 6, plus 9 into 4, 36. Next, minus 10 into 8 is minus 80, plus 1 ones are 1, plus 7 fours are 28. So this is equal to minus 1 over 17 times. Now, what is this? Minus 5 minus 4 is minus 9 minus 18. Minus 4 minus 9 minus 8 is minus 17. Again it is minus 17. See here. Minus 64 minus 6 is minus 70. Minus 70 plus 36 is minus 34. Then what is this? 28 plus 1 is 29. Minus 80 plus 29 is equal to minus 51. This is minus 51. If you divide by 17, minus minus gets cancelled. 17 by 17 is minus minus gets cancelled. 34 by 17 is 2. Minus minus gets cancelled. 51 by 17 is equal to 3. So these are the values of x, y. So therefore, x is equal to 1, y is equal to 2, and z is equal to 3. These are the values. This is how we are going to solve a system of equation using matrix method. That's it. If you want, you can verify. Substitute these values in any one of the equation. Let us consider this equation itself. 4 into what is x? 1 minus 3 into what is y? 2 plus 2 into what is z? Z is equal to 3. So this is 4 minus 6 plus 6 minus 6 plus 6. 4 is equal to 4. This is verified. Verification if it is required. So this is how we are going to solve a simultaneous equation using matrix method. Hope you followed. Okay. So just find out the cofactors and inverse. Just multiply this inverse with a constant matrix. So how to find the cofactors? This is the procedure to find the cofactor for 3 rows and 3 columns. Okay. Now let us come to the next problem. So this is solve. Yes, x minus y plus z is equal to 4. 2x plus y minus 3z is equal to 0, and x plus y plus z is equal to 2. Using matrix method, we have to solve. Now let us write down the coefficients. Here a is equal to, check whether it is in order. Yes, coefficient of x is 1, y is minus 1, z is plus 1. And for the second equation, coefficient of x is 2, y is 1, z is minus 3, and the coefficient of x, y, z are 1, 1, 1. And b, what is b? B is nothing but the constant matrix 4, 0, 4, 0 and 2. And x is equal to, as usual, x, y, z. The solution is x is equal to a inverse into b. Now first find out the inverse. For that, let us find out the determinant of a. Determinant of a is, so 1 minus 1 1, 2 1 minus 3 1 1 1. Simplify this. Plus minus and plus. This is equal to 1 into 1 ones are 1, minus into minus plus 3, minus into minus plus 1 into this row and column is gone, 2 ones are 2, minus into minus plus 3 plus 1 into this is gone, 2 ones are 2 minus 1. So this is equal to 1 into 4 plus 1 into 5 plus 1 into 1. So this is 4 plus 5 plus 1. This is equal to 10. So determinant of a is equal to 10, not equal to 0. Now let us find out the cofactors. Now what is the solution? Therefore solution x is equal to a inverse into b. Let me take after finding the cofactors. I will go to the next page and will start with the cofactors. So a, what are a? 1 2 1, 1 2 1, then minus 1 1, minus 1 1 1, and 1 minus 3 1, 1 minus 3 and 1. So the signs for this are plus minus and plus, plus minus plus, plus minus plus, minus plus, minus plus minus plus, minus plus minus, plus, minus and plus. So the diagonals are positive. Just write down the cofactors. Cofactor of first element A11. This row and column is deleted. 1 ones are 1 plus 3 is 4. Similarly, cofactor for the second element -1 is, it is negative. This row and column is deleted. 2 ones are 2 minus 2 ones are 2, minus into minus plus 3, this is equal to -5. Similarly, cofactor of 1 is equal to plus, this row and column is gone, 2 ones are 2 minus 1 is 1. This is how we are going to find the cofactor for the first row. Now let us come to the second row. Cofactor for the second row. Cofactor of 2 is equal to, this is negative sign minus, this row and column is gone, -1 into 1 is -1, -1 is minus of -2 is +2. Similarly, cofactor of 1, this is positive, this row and column is denoted, 1 ones are 1 minus 1, 1 minus 1 is 0. And cofactor of this -3, cofactor of -3 is minus sign, this row and column is deleted, 1 ones are 1, minus into minus plus, 1 plus 1 is 2, -2. Okay, right. Now let us come to the third row. Cofactor of third row, come to this 1. If the sign is positive, this row and column is deleted, 1 3s are 3, -1 is +2. Next, cofactor of next element is 1 is minus, this row and column is gone, 1 into -3 is -3, -2 ones are 2, this is minus of -5 is +5. And the last element, cofactor of 1 is equal to, this row and column is gone, 1 ones are 1, minus into minus plus 2, that is equal to 3. So therefore, straight away you can write the adjoint or cofactor. So the adjoint of A, I can write the adjoint of A is equal to, instead of writing first row, second row, third row, we can put it in the form of a column. First column 4, -5 and 1. Second column 2, 0 and -2. Third column 2, 5 and 3. This is the adjoint. That's it. Okay. Now the inverse is given by, therefore A inverse is equal to 1 over determinant of A into adjoint of A. A inverse is equal to 1 over determinant of A is 10. Determinant of A is 10. 1 over 10 into, this is 4, 2, 2, -5, 0, 5, 1, -2 and 3. This is the inverse. Now let us come to the first page for the solution. The solution is given by x is equal to, solution is x is equal to A inverse B. What is x? X, y, z. A inverse 1 over 10 into, 1 over 10 into these elements. What are the elements? These elements 4, 2, 2, 4, 2, 2, then -5, 0, 5, -5, 0, 5, then 1, -2, 3, 1, -2, 3 into, what is B? B is equal to, this is B, 4, 0, 2. Now simplify this, simplify. Now matrix multiplication. So first row, first column. Here 1 by 10 as it is, 4 4s are 16 plus 0 plus 2 2s are 4. First row, first column finished. Go to the second row and first column, -5 4s are 20 plus 0 plus 5 into 2 is 10. Again, third row, last column, 1 into 4 is 4, -2 into 0, 0, plus 3 into 2 is 6. So this is 1 over 10 into 16 plus 4 is 20, -20 plus 10 is -10, 4 plus 6 is plus 10. So therefore the matrix x, y and z is equal to, divide 20 by 10 is 2, 10 by 10 is -1, 10 by 10 is +1. So therefore x is equal to 2, y is equal to -1, z is equal to +1. These are the values of x, y, z. So therefore x is equal to 2, y is equal to -1, z is equal to +1. If you want, you can verify. For verification, if you want to verify, let us take this equation itself. x plus y plus z is equal to 2. What is x? 2. What is y? 1. What is z? 1. So minus 1 plus 1 gets cancelled. 2 is equal to 2. The answer is correct. That's it. So if you solve this much, you will get 5 marks. This is a definite question for 5 marks. Definitely you will get this type of questions. Okay. The thing is, you should be fast in writing the steps, and the signs are very important. Negative and positive signs are very, very important. Once if you lose a simple sign, the answer will be changed, so you won't get the marks, right? Then let us come to a next problem. Similar type problem can be asked in this method. Come to this method. Now, if a is equal to 2, minus 5, minus 3, 5 and 3, 2, minus 4, 1, minus 1, 1 and minus 2, find A inverse. Inverse of this matrix is to be determined. Using A inverse, solve the system of equations. The equations are given. What are the equations given? 2x minus 3y plus 5z is equal to 11, 3x plus 2y minus 4z is equal to minus 5, x plus y minus 2z is equal to minus 3. Now this is the equation. Finding the inverse for this matrix, solve the system of equations. So nothing to worry. Just observe carefully. Here what is given? They are already given the matrix A itself. See, check whether it is in order or not. X, Y, Z constant, X, Y, Z constant, X, Y, Z and constant. Write down the coefficient. What is A? A is nothing but the coefficient matrix. What is the coefficient of X? 2. And coefficient of Y is minus 3. Z is 5. Then coefficient of X is 3, Y is 2, Z is minus 4. Coefficient of X is 1, Y is 1, Z is equal to minus 2. See, this matrix and this matrix are same. 3 minus 2, 5, 3, 2, minus 4, 1, 1 and minus 2. So, to solve this simultaneous equation, we are going to find the inverse. That we know. Without finding the inverse, you cannot solve. Just proceed as usual. That's it. Nothing to worry. So, you will get the inverse. After getting inverse only, we are going to solve. Now, the inverse is given by A inverse is equal to 1 over determinant A into adjoint of A. And the solution is given by the solution for the matrix. Solution is X is equal to A inverse into B. Now, let us find the determinant of this. So, determinant of this is determinant of A is equal to determinant plus minus and plus 2 into 2 2s are 4 minus 4 minus minus into minus plus 1 4s are 4 minus into minus plus 3 into this is gone 3 2s are 6 minus into minus plus 4 again plus 5 into this row and column is deleted 3 1s are 3 minus 1 2s are 2. So, this is equal to 2 into 0 plus 3 into minus 2 plus 5 into 1. So, minus 6 plus 5, this is equal to minus 1. Determinant of A is equal to minus 1. Okay, now just find out the cofactors. You will get the inverse. That's it. Let us find out the adjoint for this. Now, let me go to the next page. I will take this A matrix. Determinant of A is equal to 2 minus 3 5, then 3 2 4, then 1 1 minus 2. Now, write down the cofactors. Plus, minus, plus, minus, plus, minus, plus, minus and plus. Diagonals are positive. Cofactors. Cofactor of 2 is equal to, this row and column is gone, minus 4, minus into minus plus 4, this is 0. Next, cofactor of second element, minus 3 is minus, this row and column is gone, minus 6, 3 2, yes, this row and column is gone, 3 2s are 6, minus into minus plus 4, this is minus of minus 2 is plus 2. Okay, then cofactor of law of third element, 5 is equal to, this row and column is gone, 3 1s are 3 minus 2 is 1. 0, 2 and 1. Second row. For the second row, let us write the cofactor. Cofactor of 3 is equal to, sign is negative. This row and column is gone. 3 2s are 6. Minus into minus plus. Again, this row and column is gone. 1 5s are 5. So, this is minus 1. So, the cofactor of next element, cofactor of 2 is equal to plus this row and column is gone. 2 2s are 4. Minus 4. Minus 4 minus 5. Minus 4 minus is minus 4 minus 5 is minus 9. Again, cofactor of minus 4. This row column is gone. What is left? This row and column is gone. 2 1s are 2. 2 ones are 2 ones are 2, minus into minus plus 3, this is equal to 5. So minus 1, minus 9, 5. Now let us come to the last row. Cofactor of 1, last row, this is gone, minus into minus plus, 3 fours are 12, minus 10, this is equal to 2 plus 2. Again cofactor of, see this element, 3 minus into minus plus 12, 5 twos are 10 is 2. Next cofactor of this element 1, cofactor of 1 is equal to minus, this row and column is gone, 2 fours are 8, minus 8, minus 5 threes are 15. So this is minus of minus 23 is plus 23, and the last element minus 2, it is positive, this row and column is gone, 2 twos are 4, minus into minus plus 3 threes are 9, that's equal to 13. Okay, I'll straight away write the adjoint. Adjoint of A is equal to, instead of writing first row, I will write first column 0 2 1, 0 2 1, again minus 1, minus 9 and plus 5, and the last row is 2, 23 and 13. This is the adjoint. Now therefore the A inverse is equal to 1 over determinant of A into adjoint of A. What is determinant of A? Is minus 1. So 0 2 1, minus 1, minus 9, 5, 2, 23 and 13. So 1 by minus 1 means just multiply each and every element by minus, that's it. 0, this is plus 1, minus 2, plus 9, minus 23, minus 1, minus 5 and minus 13. This is the inverse. Now substitute here, that's it. Now the solution x is equal to, therefore x is equal to A inverse into B. What is x? X, y, z. A inverse is A inverse. This is the inverse. That is determinant 0, matrix 0, 1 minus 2 into minus 2 9 minus 23, minus 2 9 minus 23, again minus 1 plus 5, minus 1 plus 5, minus 13. And what are the values of B? 11. So 11 minus 5 minus 3. So this is equal to 0, minus 5, minus into minus plus 6. 11 twos are 22, minus 9 into 45. 9 into 5 is 45, minus into minus plus 23 into 3 is equal to 69. Next, minus 1 into 11 is minus 11, plus into minus minus 25, again minus into minus plus 13 threes are 39. So if you simplify this, 6 minus 5 is 1. So here 69 minus 45 minus 22 is minus 67 plus 69. Plus 69 minus 67 is plus 2. This is plus 2, and again, so this is 39. Minus 25 minus 11 is minus 36. Minus 36 plus 39 is plus 3. So this is equal to plus 3. So therefore, the value of x is 1, y is equal to 2, z is equal to 3. This is very important. So see, once if there is a mistake, see, this is very important, plus minus, plus minus, plus minus, plus minus. Once if there is any small mistake in the sign, definitely, so you won't get. So here this is plus minus, plus minus, plus minus, plus minus, plus minus, plus minus. This is very important, since a small mistake will also changes the answer. So this is plus minus, plus minus, plus minus, again plus minus plus, so that will give the answer. Okay, that's it. Okay, now let us come to the next problem. Now what is the problem given here? The statement problem. The sum of three numbers is x. Sum of three numbers is x. If you multiply the third number by 3 and add the second number to it, we get it as 11. By adding first and third number, we get the double of the second number. Represent algebraically and find the numbers using matrix method. So, we have to formulate this equation, and this equation can be solved using matrix method. Now, let us consider the three numbers. Now, let the three numbers be x, y and z. Now, what is the given condition? The sum of three numbers x plus y plus z, sum of three numbers is 6, first equation. And the second, if you multiply third equation is z by 3z, and second number to it, add second number to it is y, we get it as 11. So, that means y plus, so x is not there, 0x plus y plus 3z is equal to 11. Now, the third condition, by adding first x and the third z, by adding the first and the third number, we get double the second, 2y. So, x plus z is equal to 2y. So, this can also be written as x plus z minus 2y. So, transfer this can be written as x plus y becomes minus 2y plus z is equal to 0. This is the answer. Check. X plus y plus z is 6, 0x plus y plus 3z is equal to 11, x minus 2y plus z is equal to. So, this is solved using matrix method. Now, let us write the coefficients. Now, I will write the coefficients. So, here a is equal to, this is an order 1, 1, 1 and 0, 1 and 3, and the coefficient of x is 1, y is minus 2, z is 1, and x is equal to, as usual, x, y, z, and the matrix B is equal to, what is B? 6, 11 and 0. The solution is x is equal to A inverse into B. That's it. Now, let us find out the inverse. I will go to the next page. Now, determinant of A is equal to determinant 1, 1, 1, 1, 1, 1, 0, 1, 3 and 1 minus 2, 1, 1 minus 2, 1. Simplify this. This is equal to plus, minus and plus. 1 into 1 ones are 1, plus 2 3s are 6, minus 1 into this is gone, 1 0 0 minus 3, plus 1 into this is gone, 0 minus 1. So, this is equal to 1 into 7 minus 1 into minus 3 plus 1 into minus 1. This is 7 plus 3 minus 1. 10 minus 1 is equal to 9. Determinant of A is equal to 9. So, inverse exists. Now, find out the cofactors. So, therefore, the signs, this is very important, plus, minus, plus, plus, minus, plus, minus, plus, minus, again plus, minus and plus. Diagonals are positive. The cofactor of 1 is equal to 1 ones are 1, minus into minus plus, 2 3s are 6, this is equal to 7. Next, the cofactor of 1, the sign is minus, this row and column is gone, 0 minus 3. This is minus of minus 3 is plus 3. Again, cofactor of 1 is, this row column is gone, 0 minus 1 is equal to minus 1. 7, 3 and minus 1. Similarly, let us come to the second row. I will find the cofactors. Cofactor of 0. The sign is minus. This row and column is gone. 1 ones are 1. Minus into minus plus. 1 plus 2 is 3. That is minus 3. Again, cofactor of 1 is equal to, the sign is positive. This is gone. 1 ones are 1 minus 1. That's equal to 0. And third element, cofactor of 3 is equal to, the sign is negative. This row and column is gone. 1 into minus 2 is minus 2 minus 1. Minus 2 minus 1, minus of minus is plus 3. Now, come to the third row. Cofactor of 1 is equal to, the sign is positive. This row and column, 1 3s are 3 minus 1. 3 minus 1 is 2. Again, cofactor of minus 2 is equal to minus, negative. This row and column is gone. 1 3s are 3 minus 0. This is minus 3. And finally, cofactor of last element 1 is 1 minus 0. This is equal to 1. Now, therefore, the adjoint, I will straight away write the adjoint of A is equal to, adjoint of A, first column 7, 3 and minus 1. 7, 3, minus 1. Second column minus 3, 0 and plus 3. And the third column 2, minus 3 and 1. This is the adjoint. Now let us come to the inverse. I will go to the first slide. From this, therefore, A inverse is equal to 1 over determinant of A into adjoint of A. What is determinant A? Determinant is 9. 1 over 9 into adjoint. What is adjoint? This is 7 minus 3, 2. 7 minus 3, 2. Then 0, 3, 0 minus 3. 3, 0 minus 3. Again minus 1, 3, 1. Minus 1, 3 and 1. Now therefore, the solution x is equal to A inverse B. Solution is x, y, z is equal to 1 over 9 into 7 minus 3, 2, 3, 0, minus 3, minus 1, 3, 1 into B. What is B? 6, 11 and 0. Simplify this. This is 1 over 9 into first row, first column. 7, 6 are 42. Minus 3 11s are 33, plus 2 into 0 is 0. Again 6 3s are 18, again 0, again 0. Again minus 1 6 are 6, 3 11s are 33, plus 0. Now what is this equal to? 1 over 9 into, let me rub this, then 18 minus 0 is 18. 33 minus 6 is plus 27. So if you divide, what you will get? 9 1s are 9, 9 2s are 18, 9 3s are 27. So therefore, the value of x is 1, y is 2 and z is equal to 3. So therefore, the three numbers are 1, 2 and 3. That's it. So what is the equation we have obtained? If you want, you can go for the verification. What is the first equation? Three numbers is 6. X plus y plus z is equal to 6. Verify. 1 plus 2 plus 3. 6 is equal to 6. Right. Correct. The sum of three numbers is 6. 1 plus 2 plus 3 is 6. That's how we are going to solve this equation. That's it. These are very, very important problem for 5 marks. Usually you will get a straight question of solve a system of linear equation using matrix method. For that, just find out the value of A, x and b. The solution is given by x is equal to A inverse b. A inverse is equal to 1 over determinant of A into adjoint of A. The solution x, y, z is 1 over determinant A into adjoint of A into B. That is x is equal to A inverse B will give the value of x, y and z. That's it. So that's all regarding this session, and that's all regarding this determinant also. So if you read matrices and determinants, if you practice all these type of problems in matrix and determinants, definitely you will get 11 marks in matrices and 19 marks in determinants. Totally you will get 30 marks from these two chapters. Okay, this is very, very important and very easy. Okay, that's all regarding today's session. Let us meet with a different concept in the next session. Thank you very much.